So we would use English, yes? As I understood. Okay. Okay. So we are starting session 8, distributed systems and telecommunication and network. And here we have 2 presentations and three poster presentations. We will start with Arsak Manasan, Roberta Devasan, and Rasha Satran. Sessions learned from Master Time Network Simulation. So please, Arsak.
Hello everyone. Today I introduce you work that have been simulated all, and it's based on our research that have been published. It's about the lesson learned from ASNet AM network simulation. I will present our presentation based on our research and infrastructures are the same, I can say. In our article, we evaluate benefits of modeling national research and education networks facilities in the Armenian ASNet AM case. Several models and operational variants have been developed and evaluated using the GNS3. The study demonstrated the benefits of using the modeling platform as an excellent substitute for complex and expensive network equipment. On the picture, you can see the Armenian ASNet AM topology. Within there is our core routers, and about this I will introduce next. In introduction, we show you that high performance, secure and reliable communication networks are critical in the meeting increasing demands of research centers and universities. So NRS effectively leverage communication and modern computer technology to interconnect the data communication across continents through the pan-European giant network. So NRS provide academic and educational institutions with computationally intensive resources like high performance computing and cloud computing, as well as data related infrastructure such as data centers and repositories. The services are built on robust computer networks that ensure network interconnectivity, large data transfer capabilities, and high performance large scale simulations. Traditional network administrators having used test infrastructure comprising physical components like cables, routers, switches. So they need strong monitoring tools, virtualization that can help in their work. So in our work, we have been used the network virtualization and simulation that will help us get results and then simulate our network in real. So network virtualization techniques enable the abstraction of network resources either by dividing a single physical network into independent virtual networks. This virtualization software allows seamless access to this virtualization dividing and by creating a network overlay. The software enables the operation of these things virtual network layers on top of the network physical fabric. And the network virtualization, with this, we save time by streamlining the internet infrastructure provisioning process for supporting new application. And with our paper, we want to show that it addresses the challenges of ensuring flow security, monitoring early error detection, collision reduction in developing the diverse systems and services, including new mode management software and tools. So our main aim to study the evaluation results and valuable lessons from the ASNet AM network simulation, shedding light on practical approaches into enhancing network performances. In our methodology, I will introduce that the basic ASNet AM network topology consists of core routers, as I have shown you earlier. The backbone network emulated utilized 10 gigabits links to ensure optimal connectivity between the core routers located in POPs and the connected nodes in terms of routing protocols, the network topology, encrypted distributed routing protocols that BGP and OSPF that makes the optimization in our network. In this table, you can see our routers parameters like CPU, CP ports, and RAM, which we are using in our network in real in our simulation. Here you can see our network topology that have been simulated in GNS3. Here are our four core routers that interconnected with routers and devices. So here we have been simulated all our network in GNS Requiem in Cloud Labs by using large resources of Cloud Labs because it gave us opportunity to test our network within their large resources. Here I can show you Cloud Labs platform, where in this node we have our all topology simulated by GNS3. For monitoring, as I have said, that our administrators need more monitoring tools to find the problems faster and solve them faster and easily. We have been using Zabbix open source platform, and Zabbix have strong alert systems. With Zabbix we can see the problem when it ensures and how long the problem has been in our network. And also, as you can see in the corner, I don't want to say, we can get alerts with Zabbix, which will show us the problem. When it has been started and when it resolved. And also with Zabbix monitoring system, we can see graphs of our network traffic, like about links, and we can get data like CPU temperatures, when status, and ICMP loss, ICMP ping. And we can also get graphs with other platform like calling Grafana. And by simulating and getting data from these programs, we saw that also in Grafana. Here we can get data from Zabbix and then create our graphs that what we need. To study, examine the failures, packet loss, latency that occur during network operation. We increase the traffic to see how the network would behave in such case. We close to one part, for example, giving priority to another part of the network and vice versa. Again, observing the change in the results about network monitoring, we use Zabbix, where we have gotten all the needed information from, for example, as I said, ICMP ping to device, Q temperature, and that. It depends on what we need to increase. So the result of our research was we have already tested and fully pre-configured network. The case we were able to get a pre-configured and tested network using the large resources available on the Cloud Lab. And then based on the results of the experiment and already understanding the risk, we implement the same in the real network. So that's all. If you need, we can also show you that platform we have created and real time with Zabbix and Grafana. So That's all. Thank you.
Any questions? Please.
I have this question about GNS3 that we used and you said. Thank you. Okay, so you said you're using GNS3 and Zabbix to monitor the whole network, even if you create it in virtualized mode. But you didn't mention about the bandwidth. Can you measure the bandwidth too with GNS3 and the Zabbix, and
Of course,
the relation between the Zabbix and GNS3? I know they're totally different software, and you integrated Zabbix with GNS3. Can you explain it more if it's possible?
of course,
Thank you.
in GNS3, we get a real network topology that contains all configuration that we have in real network. So when we integrate GNS3 for with Zabbix, Zabbix can already get all data from our devices by SNMP protocol. That is simple network management protocol that gave all information about our devices to the Zabbix. And we can see all the data, include bandwidth of our network, the cutoff by cutoff the year. So we don't have that problem that we cannot have our bandwidth. So.
If you want to say another word, it means that these two products have the same data of real network. That is why their graphs will be identical. Yeah, you're using GNS3 to monitor content.
Yes. And of course, now we have Zabbix in our network. We tested and it's working so good. So I can see our alarms. I can show our alarms we get from Zabbix every time. It's we are doing with Telegram bots. So every time that some device is going down, we get messages in Telegram. So we can solve the problem faster than we can do it. So, thank you.
Other questions? Please.
Thank you. What parameter do you consider in your simulation? For example, end-to-end delay, jitter rate, packet loss rate, and do you have, for example, and try and error check it? That is what the better network. Okay.
In our network, we scan our network with this monitoring system. So it's getting from our network topology everything we want. So in the monitoring system, we can see all latest data or latency that links cost and also how many gigabits that links can put the traffic from one side to another. And
thank you.
Other questions? If we have no questions, we can thank Arsak. Now, next presentation. Evgeny Petrosyan, Evgeny Prokhorenko, and me. Development of the concept of system for collecting and visualizing statistical network traffic data in the OSNetM network.
Hello, my name is Evgeny Prokhorenko, and we have many interesting things in our network, which we partly created or partly implemented already solutions. For for you better to understand what is going on, let's start with the history of the network. As you know, at first, if somebody just want to have, for example, internet in some educational institute, they at first must create one LAN, local area network, and then with from time to time we will get more and more devices for our network, and from some time we just need some devices, I cannot say, which will show us weather on our network. By the way, there is an interesting program called Weather Map. Weather Map is the program which can show at the same time all data flow from outside of our network and from outside to our network, and then we know that by the rules of RIPE, RIPE is Internet European Internet company, and they are giving IP addresses to the institution, and they just must to use some percent of this IP addresses for to help easy with the easy with efficient. So it means that when we have networks more than /24, what is /24? /24 is okay, and from some time we understand that it is not enough to have only one way to the internet from our network, and it means that we need to have a second internet service provider, and with this configuration we need somehow to know how to manage packets which are trying to leave our network or come in. And we need to know on what interface we will send our information. In the from this time, we, for example, in our institute, we find out that there must be special servers which measure what is the flow of information, and our idea is to show this information in most nice form, because if you will just read all the data which you can reach for every monitoring device, it means that we will not have idea how we can change our network to be more effective. And I think that sometimes it's considered as a minus, but it is plus that the different devices have a different type of information which they can get from the network. For example, here we just see that it is the SNMP protocol. There are also many protocols for switches. We know that routers and switches are different devices, and each has its own parameters. And here we see that how can we combine information from different interfaces to have visibility of all what is going in our network. So let's imagine, and it is a real situation now, that we have so-called network backbone. Backbone is just a line of routers from the border. On the border, we have border router, and after information goes to our network, and we can see graph where we see only what is going on the border. But it is a very simple configuration that I told that it is one border router, maybe two core routers, but we need more complex things. So here are examples of information that we can get, which is it is divided by our clients. So, clients of our we are an internet provider, and we have in many connections to the internet. For example, now I can tell that we count how many connections we have from other networks, and it is about 70 institutes. Mainly, we are working with the universities, then research institutes, and each of these institutes, depending on the complexity of their network, just have their own graphs if they need it. But for the whole picture, we can show something like this graphs. And idea is that usually when somebody trying to create such monitoring system, they have all data in one line, and in this case, it is not visible all situation. And but when we divide this information by first for border routers, we connect border routers graph. Then we have the core browsers. They also will show us interesting things. The problem is that if we'll think that we have several core routers, and we combine it in one graph, it is just not mean that we have each packet only one, because packet it can go such a way that and you can see that. For example, you send a packet to a core router get it back for you, and it means that something is wrong in your network. So we have this program, and it is very useful for us because at first glance you see everything which is going on, and in the future we will try to create software which will show us what is different type of information, because we can not count every packet, but for example, we will tell that I want only DNS traffic, and we will see where is DNS traffic going, because for example, it is a real situation that some DNS is not working and your network is not working too. Okay, I think that that is all for the moment, and we will continue to work with this data, and you can understand that this in this situation we will have all needed information for not for network administrators, because they have their information in their network, but here is just for big bosses. When a big boss will see high value on the graph, he would okay, who is there, and you must answer him what is going on.
Thank you so much, Jim. Any questions regarding this presentation? If not, we can thank you. Now let's go on with poster presentations. We first will listen to Timur Jamharian, Network Intrusion Detection System Performance Measurement Model, please. So Timur said that the presentation will be in Russian.
Приветствую вас, участники конференции CSIT2023. Я Тимур Джамхарян, представляю вам тему доклада «Модель измерения производительности сетевой системы обнаружения вторжений». Значит, актуально? Слышно? Слышно? актуальность, значит, темы. Производительность всей системы обнаружения вторжений складывается из производительности ее отдельных компонентов и правильной их конфигурации. Это такая аксиома. Значит, в классических системах обнаружения вторжений, под классическими системами обнаружения вторжений мы понимаем детерминированные системы. Это SNOR, суррогат, если open source, или там Cisco NGFO, firewall различные. Ну, нет. Значит, активируем все правила и максимальную глубину погружения, мы получаем тот аппаратный ресурс, который нам необходим. Для гибридных СОВ или СОВ, построенных полностью на основе машинного обучения, из-за их вероятностного характера работы назвать точное значение потребляемого ресурса довольно затруднительно. Или можно только условно, с той или иной, подчеркиваю, вероятностью можно сказать, сколько аппаратного ресурса нам необходимо. Значит, правильная оценка производительности системы с машинным обнаружением позволит ответить на два важных вопроса. Первый вопрос. Какой ресурс необходим для функционирования самой системы обнаружения вторжений? И второе, какую мощность пространства атак способна отбить данная система обнаружения вторжений? Значит, цель работы – разработка метода оценки расчетного требуемого аппаратного ресурса для СОВ с машинным обучением. Значит, некоторые определения, чтобы было. Модель производительности. Чтобы не читать то, что написано на экране, просто скажу двумя словами. Модель производительности – это то, что мы собираемся мерить. Вот из этого всего пространства производительности те метрики или те параметры, которые нам необходимы. Второй – эффект наблюдателя. Ну, все понятно. Машинное обучение – вероятностная вещь. Мы сами вторгаемся и нарушаем ее действия. И некоторые определения по нейронным сетям, применяемым в данном исследовании. Значит, в моем предыдущем выступлении я подчеркнул, что было несколько способов решения данной задачи. Первым способом мы пытались внедрить метод с применением нечеткой логики, fuzzy logic, и нейронную сеть Кахонина. К сожалению, данный метод нам давал выигрыш только при обнаружении полиморфного ПО, а остальные все метрики прочие метрики не могли с данной заданной достоверностью определять. Было принято решение отказаться от применяемого данного метода, то есть мы изъяли нейронную сеть Кахонина из системы, плюс отказались от самой парадигмы построения на основе нечеткой логики. Было принято решение решить задачу, концептуально поменять и решили задачу математически. Значит, вот система обнаружения вторжений, ее компонентный состав. У нас есть 4 нейронные сети, модель производительности которых надо замерить. То есть мы на выходе должны сказать, какой ресурс нам необходим для их функционирования. В качестве тестовых данных использовалось победоносное ПО как в обфусцированном, так и не в обфусцированном виде. Оно указано на слайде. И различные модификации, потому что генеративно-состязательная сеть, входящая в состав данной системы обнаружения вторжений, подготовила свыше 100 тысяч коллекций наборов данных различных размерностей. Как небольшую ремарку отмечу, что некоторые коллекции наборов данных не обнаруживались даже публичными сервисами обнаружения вредоносного ПО. Вирус Total не видел модифицированную модель Mimikatz. Это ПО атаки на Active Directory. Значит, небольшое такое допущение. Для запуска системы обнаружения вторжения SNORD в режиме максимальной производительности. На сайте немножко данные другие, но мы практически это проверили. Чисто для ее нормального функционирования необходим вычислительный ресурс с процессором не меньше, чем i7, и минимум 64 гигабайта. Это для функционирования этой системы. Какую мощность атак она должна отбить, это совсем другой вопрос. Значит, применяемый метод. Мы применили метод минимизации функций методом неопределенных коэффициентов. Просто минимизируем метрики данных, скажем так, наборы данных минимизируем. И из всего пространства производительности было выбрано 4 метрики. Метрика 1 – количество запросов в единицу времени, в данном случае в секунду, то есть время реакции, если так скажем. Второй – временной интервал между началом и окончанием срабатывания, потому что это тоже важное. Система обнаружения вторжений работает не такой термин standalone, она работает в комплексе. То есть если одна обнаружила, система ECM должны передавать данные на другую. Вот это комплексное решение. Третье – пропускная способность самих нейронных сетей. Не системы, а самих нейронных сетей. И, понятно, утилизация процесса и оперативного запоминающего устройства. Значит, тут некоторые выкладки. Что мы получаем на выходе? Минимизируя вот эти 4 параметра, извините, не 4 параметра, минимизируя набор данных, которые нас приводят к этим 4 параметрам, разработано ПО. Во-первых, ПО позволяет сразу, вот алгоритм я представил вам, значит, мы сразу можем установить, какой параметр мы хотим замерить. на какой параметр затачиваем конкретно в данном режиме работы данную систему обнаружения вторжений. Ну, остальное уже выходные действия, циклы библиотеки, что-то так. Значит, ну это... Значит, подгружаемые данные. Это очень большая проблема. Датасеты вредоносного ПО найти невозможно. Так скажем, в кавычках невозможно. Потому что публичные сервисы, эти датасеты уже скомпрометированы. Не публичные сервисы, но это криминал, если вы будете разрабатывать ПО и внедрять его. То есть некое необходимо разрешение соответствующих структур. Отвечу так на этот вопрос. Значит, это первая модель, сейчас она уже функционирует на реальной сети. Это первичная модель, где мы проверяли в операционной системе Windows Server 2016 в среде Hyper-V, ну, развернута виртуально программно определяемая сеть. Что получили на выходе? В результате исследования. Вот результаты тестов. Значит, первый верхний тест – это без минимизации, второй – с минимизацией. Первично, значит, зеленый, смотрите, растет всегда пропускная способность нейронных сетей. Вот здесь зеленое выделено. Второе, растет время отклика. Вот это, нет, уменьшается время отклика. Но плата задачи оптимизации мы теряем в оперативном запоминающем устройстве. То есть, если здесь была малая загрузка процессора, большой АЗУ, здесь наоборот. Тут то же самое. Значит, как результаты исследования. Во всех случаях ввода вредоносного ПО, как единичным, потому что вводилось как один тип только ПО, так и массовая шла так, внедрение. После минимизации уменьшается время запроса и время срабатывания. Но я здесь не стал это отмечать. Сразу скажу, также растет параллельно false positive. Ошибки второго рода рост экспоненциальный. Надо найти вот эту точку оверфитинга, переобучения нейронной сети, и остановить в этот момент. Значит, увеличивается пропускная способность, она тоже связана напрямую с аппаратными возможностями. Мало применять, допустим, большое количество оперативной памяти. Оперативная память должна быть, во-первых, высокого качества, скажем так, HyperX, DDR4. Но если сеть развернута в виртуальной среде, есть такой термин balloon memory, чтобы она перекачивалась, эта операционная память между собой. Значит, что для нас? Для нас важно было последние два пункта. Значит, мы с вероятностью где-то 0,7-0,8 можем уже сказать, какой потребляемый ресурс нам нужен при развертывании системы обнаружения вторжений в данном комплексе. То есть нам нужна высокая производительность, высокая пропускная способность. Мы затачиваем ее под нее и говорим, вот такой аппаратный ресурс. Необходимо высокое время реакции. Мы уже объясним, что вот для этого нужен процессор такого класса. А суммарно, значит, происходит снижение обрабатываемых наборов данных в 2,13 раза. Это четкое число без потери репрезентативности. То есть мы не теряем вот эту репрезентативность данных. Вроде все. Да, все. Благодарю за внимание. Вопросы, если есть.
Thank you. If you have any questions, I think it would be difficult if you don't understood Russian, but anyway, please.
Russia. My alma mater is Russia University. Please, Russia.
Так, бесспорно, каждое исследование ведет к конкретному результату. Если я вас попрошу методу неопределенных коэффициентов.
Сами формулы?
Да. Минимизация. Это вы использовали четкую логику.
Это бинарно.
Это булевая алгебра. Да. Но если учесть атаки, эти вторжения и тому подобное, без machine learning, без artificial intelligence, тут не обойтись. Но зачем вы столь упростили проблему задач?
Скажу так.
Куда это вас ведет?
Куда это нас привело? Первоначально стояла задача подготовить модель для 28 метрик. Потом количество метрик, когда убавилось, стало на 4. Простота – залог надежности.
Да.
Это решение, которое приводит нас к решению достижения цели. У нас цель – снизить набор данных и повысить эту производительность. Мы это добиваемся.
Я просто вам желаю удачи.
Нечеткая логика нас...
Не надеюсь. Я желаю удачи.
Еще добавлю, первично мы использовали нечеткую логику, вот я здесь подчеркивал, это фазы логики. Но она нас завела в такие дебри, что, извините, там это отдельная диссертация получилась бы. Только вот ради этой нейронной сети отдельная диссертация получилась бы.
Okay, thank you. Спасибо. Please.
что это где-то при...
Да, мы используем это. Мы используем
Как вы его
это в
используете?
одной государственной организации. Какую, я отвечу вам.
Нет, это не принципиально. Я имею в виду, что
мы используем
она
только
настолько надежна, ее можно реально использовать, и она дает результаты.
Она работает в комплексе с другими, во-первых, системами, потому что это все-таки экспериментальная модель, и сказать, что она как 100% результат дает, нет. Но я назову дату, вы меня поймете. 27 сентября 2020 года у нас было большое количество эвентов, событий, которые стандартные NGFO firewall их не обнаруживали, данная система обнаружила. Потом мы проверили вот этот пикап-файл, дамп-файл проверили. Да, там было вредоносное ПО. Более конкретно, там был WAN-кру модифицированный, что могло нас за час, за два поставить перед атакой на доступность на инфраструктуру. Система вовремя среагировала и перевела вон из-под трафика.
Хорошо. Спасибо.
Thank you. Other questions? Thank you. Thank you. Now we have next poster presentation, Edita Gichun's performance for general symmetric and triangular matrix multiplication for multiple GPUs. If I don't know if maybe she's not present here, so we will have our last presentation that I will present. If Edita is not here, as I understand. My presentation, I will present it from there. So in this session, this will be the last presentation. We will talk about EDROM in Armenia, success and challenges. Our paper regarding EDROM presents our progress in this area, but first of all, on this slide, I would like to introduce you what EDROM is, because it is not so widespread yet, and we hope that thanks to this presentation, and thanks to our efforts, more and more institutions and community would understand the profits of using EDROM technology. It's about secure Wi-Fi roaming service developed for international academic and research communities. So we all know what Wi-Fi is, and we use it, most of us, because we want to have mobile devices connected to the internet. But mostly we use Wi-Fi connection for personal networks. So it could be some network within some institution or within our home. And when we connect to Wi-Fi, our device presents for connection some code which is same for all devices connecting to that. But when you use EDROM, you have a personal, your identifier, your credentials for connecting Wi-Fi. And more is that when you connect to some Wi-Fi device, you can connect it wherever EDROM exists worldwide. And currently, it exists in many, many places outside our country. And I will show you some places where it exists now in Armenia also. So basic principle is that authentication is done by user's home institution. So you should be registered your institution if you are a researcher or a staff of some academic or institution or university, or you are a student. Your institution should participate in EduRoam. If your institution participates in EduRoam, you should have a credential at your institution, which will allow you to connect to EduRoam, presenting your username and password. And this authentication is always done at your institution's server. But Wi-Fi access of your device is given to you at the place where the coverage of EduRoam exists. For example, it could be anywhere where EduRoam is currently activated. In this building, for example, we have coverage of EduRoam. And if some person working at some outside university or some outside research institute from other country would come here and would turn on his device and activate Wi-Fi, it will instantly connect to EduRoam. But how will it take place? The device of Wi-Fi here in the building will first ask via a secure channel for the home institution server if this user is eligible to connect to the Wi-Fi. After getting okay and so positive response, a device will allow you to connect to Wi-Fi. So this is basic principle of EduRoam, and it was originated in 2002. Initiative started few European countries in 2003, and later other national research educational networks in Europe started joining. We also joined some years ago, and this initiative is coordinated and supported by GÉANT Pan-European Network. Most our activity current stage started in 2019 when we introduced an infrastructure boost concept, identity infrastructure boost concept. It was based on, we have published a paper on that. It was based on the fact that in Armenia, research universities, research institutions, most educational and scientific area, most organizations don't, not many, let's say many organizations either don't have or don't want to use their identity data, their users' data for other services like EduRoam. And we found some solution to provide to such institutions or universities to use their email credentials to connect to Wi-Fi. And this solution worked quite well. Since 2019, many institutions and universities started using EduRoam, allowing their students or staff to connect to EduRoam, so I mean to Wi-Fi, using their email credentials. So you enter your login you enter your email, corporate email at your university, and your password as your email password as a password to connect to Wi-Fi. Thanks to this concept, many organizations, as I said, started using that. But during that, we have had some issues because several universities moved their identity database to Google or Microsoft because it offered free services and like email service, and it required us to modify this solution to work with Google and Microsoft. And new solution we have found and already implemented for Google. Microsoft solution is in progress because yet not so interested by universities who are using it, but we are ready to work with interested partners to find solutions there also. And also we had developed previously some another solution, multi-app reduced configuration. Reduce server is a server which authenticates Wi-Fi enterprise access. And we found that many organizations in Armenia, because of being small and having small requirements, don't want or don't like to spend some resources to have their own server at their premises, but they want to use this service. So we implemented a multi-app configuration radius, which combines multiple configurations for multiple organizations at one server. And it's enough to serve tens of organizations in one server instead of having tens of servers or even containers. Maybe anyway, it would be much more than just one server running one piece of software, but ready to support multiple configurations. And currently, we effectively use this configuration. So we offer any university or any organization, if they would like to have a drone, but they don't have capacity or they don't want to have such server at their organization, we can organize it at our network, ASNetAM network, where we provide it as a service. We have a hosted solution here. Currently in Armenia, we have such situation with the coverage. So about 40 points of presence, most in Yerevan, of course. In the center of Yerevan, there is this coverage like this. Here I show at the Academy of Sciences. This is American University of Armenia, and there is Academy of Sciences. And just an example, if you visit edurom.am, you can find real-time map where the coverage is presented. Of course, it's not so much because yet not so much organizations have expressed interest. But anywhere we found this as a good result because this service is progressive service, and it is used in most universities, in most scientific organizations in Europe and other countries outside. And we hope that more and more organizations would understand that necessity, because it serves as well as students and staff, and different categories can take use of this service. Now we are ASNetAM team acting as a national roaming operator. So we provide support for all organizations who want to join eduroam. And we hope more organizations would start using it. And in my final slide, I want just to stress that there is a new solution for joining, so for connecting the devices, which is called Get eduroam, which simplifies use of this, because with this new solution developed by several European research networks together, you can easily connect your device for using eduroam on iOS, on Android, on Windows, and most platforms are much easier to connect. But this is user space part. Most and first step should be done by organization, by university or scientific research institute to connect. After that, as a user, you or I can use this application. Just select my institution. You just type your institution name, find, connect, put it your email, your password, and you connect in eduroam. And whenever you will be where eduroam coverage exists, you will get secure Wi-Fi access. Thank you. If there is no questions, I would be happy. Yes, please, microphone.
I have a question regarding the server part that you said you're going to use, let's say, one server. and you're going to connect somehow, let's say 5 to 10 small businesses, small research team to connect at one server and to go out to the internet. My question is basically focused on security part. So if you're going to use one server to connect a bunch of research teams, actually on servers, you can configure, as I know, one main group policy, main policy for outgoing networks. And let's say we have 3 types of research teams. And each research team, they work in a different way. So they need some ports to be open, and the other team, they want that port to be closed. So if you configure one thing on server, it might affect to other research teams. How you can explain it's efficient to use that part? Thank you.
Good question. I will try to answer. Let us see this slide. When I showed here that authorization, so the access decision is done by not by some server, but by visited network. So Wi-Fi device here decides what access you will have. And it decides depending on their policy, internal policy of our institution. It does not depend on the user or on some server which does authentication. The server we are talking about only implements authentication. So the server only says this is valid user or not, nothing more. Other policies are implemented locally, and eduroam policy allows each university, each place, each some coverage place to define their own policy. For example, you can visit Cambridge University, connect eduroam, and find out that some ports are closed. It's their own policy. They decide to provide eduroam, but limit some ports. And they have a right to use it to provide this service their way. But general policy is that each organization participating in this Wi-Fi roaming should get access everywhere where eduroam is. But it will be somehow filtered by some layer of local policy.
Somehow it looks like they have their ongoing policy, and you can run, let's say, different type of VMs on, let's say, AWS. For each of them, they own local policy and ongoing policy.
Yes, somehow it's like that. Thank you. Please, Robert.
But some information in additional. When you connect to eduroam, all who will be connected to eduroam will have the same policy. You cannot divide by different groups if they are connected to eduroam. If, as I remember, you mentioned that maybe you have some groups, but if they all will be connected by eduroam network, they will have same policy, same security policy, because they are connected in the same area.
Yes, we are talking about local policy.
Yes.
It will be same for all users regardless of where institutions they are from.
To connect to eduroam, they will have the same policy. It's not possible to divide. Maybe you can, in your organization, can create other Wi-Fi network with specific policy. In that case, some users should connect to that eduroam. Not eduroam, but that Wi-Fi.
Yes. For example, we have some Wi-Fi access for this conference only. It's limited for these days, and this is a separate configuration. But we have and continue to have eduroam connection separately, and it is for all connected users. It is the same for local users or outside users. It is the same for this building regarding eduroam access. Thank you. Other questions? If not, we can probably finish our session. Thank you so much for all.